All right, thank you for being here. Happy Thursday. Um, my plan for today is I have something that someone last class asked about, so I just want to show you all the different things that I do. As I go, if I do something that you don't recognize, just let me know and I'm happy to teach you. I'm all about getting people to use more like keyboard shortcuts and other things that make your life easier as a programmer. For announcements, there's an award that someone on the email list told me about. There's an award in honor of Brother Camillus, who was a very well-known and well-loved brother on campus. I took a class from him when I was a student here. And they have a scholarship or an award in his honor. And so you can apply for this and have funds for Janterm or books or anything. So if you're interested, the deadline to apply for that is beginning of March. And if you need the link or anything, let me know, and I'm happy to forward it along.
I just remembered what I was really known for,
Okay.
which was leaning my chair back all the time.
All right. All right.
Like, like real, like leaning it really back. And everyone who walked by sometimes noticed and asked, like, aren't you worried you're gonna fall? And I was like, I don't care.
Yeah. Okay. Sorry, I had a line in there that said something was due next Tuesday. This doesn't apply to you, so don't worry about that. I had copied and pasted it into there, but that doesn't apply. So homework, let's see. I should have gotten all my lab ones. I will work on grading that tomorrow. Homework one should be due today, I believe. Let's double check Canvas. I've got stuff to grade, so thank you for giving it to me. February 20th. That's today. Yes. So turn that in when you get a chance. If you've got questions about that, let me know. The next assignment is going to be lab 2, which there's currently not a due date on. Once I get to explain that, then I'll be able to decide a due date. So if you want to start on it and try and work on it as we go, feel free. But that's not required, and I'll put you in groups for lab 2 as well. Okay, so the thing that someone brought up, I don't remember exactly who. So I was doing a thing over here where, let me make a new class. Like February 20th, and I will give it a main method. Okay, so let's say I've got some lines of code here. Currently they're comments, but they could be whatever. I can move them around. Like I can move it up and down as much as I please. The way that I do that is on Mac, I hold Option, and then I use the up or down arrow key. So wherever my cursor is, so like my cursor is on this line, and I press the hold Option and press up, the line moves up. If I press down, the line moves down, all while I'm holding down Option. If you're on Windows, I believe the key is Alt, the ALT. So Option up or down or Alt up or down.
So I'm still,
Yes.
I'm at this point in downloading, I forgot what to do.
Okay. I will help you at a later point. Okay, so that's how you can move lines around. It's a fun trick. I'm gonna go over the main idea for lab 1. So hopefully this should be duh for you, but just in case there's something that maybe you're not understanding, hopefully it helps. So I'm gonna open up my lab 1. So for beginning, I have to like add a print statement. So I can say, hello here, and then there's some requirements for variables. The only thing is like int a equals 5, double b equals 1.2, Boolean c equals false, something like that. So that's the point for beginning, is to just print something and declare something. There's a bunch of warnings there because you're not doing anything with them. That's fine. So that's beginning. I'm going to close this and not save it. So that way I have a clean copy for next time. For middle, this is where things kind of started getting a little bit harder because it requires us to practice for loops. So for 4, 1 through 10, let me adjust how these are looking. So what are the corresponding code snippets in this for loop? What's the initialization here? Int I equals 1. Yep. What's the condition? I less than 11. And the update? I plus plus. Great. Those are those 3 steps. So for that one, you just need to look at it because I've given that for you. And so then for sum, so we know that we need to start at what? Because for array, the index starts counting at 0. So we need to start counting at 0. So we would say int I equals 0 is our initialization. And then for our condition, yeah. So we're going to start at the beginning and look at each thing until we've reached the end. And now that we know a little bit more about methods, hopefully this thing starts to make a little bit of sense. So we're in a method called forSum, and the method has a single parameter, which is an array of integers. So the variable name is ARR for array. The type of thing in the array is integers. And we know it's an array because of these square brackets after the type name. And so the update step is what? I plus plus, right? Yeah. And so then how to keep track of the sum as we go? What do we need? This should also be fairly simple. Yeah.
The system out print line sum plus equals ARR.
Yeah, so we'll have some variable sum and we'll have sum plus equals ARR at position I. Great. So up here we need for, and then here's our initialization, condition, and update steps. So int I start at 0. I go until we get to the end of the array and add 1 each time. We'll need some variable sum. So typically define sum. We start at 0 before the for loop. So if you just leave it like that, I think that might work maybe. But to be safe, just like if you've got a bunch of things to add, you implicitly start at 0. So we need here to explicitly start at 0. And then inside the for loop, like you said, it's just sum plus equals ARR dot. Nope, that's not correct. ARR at position I. So we're going through the array, and at each point we're picking up, here's the thing in the array, adding it to our sum. Go to the next one, pick it up, add it to our sum. And at each point in the for loop, we're asking, are we there yet? Have we reached, has I reached the length of the array? And once it has, then we're done. So once we do that, we've got our nice sum variable that holds the sum. What's the thing we need to do last? Yeah. There we go. So we just return some. And then while went through 10, the process is the same. Just figure out, this is the initialization. This is the condition. And then I++ is still the update. That's all that's required for that one. And then while sum is just do the same thing and just write the while loop instead. So we'll have int sum equals 0, int I equals 0, and then we'll say while I is less than array.length, sum plus equals ARR at position I. And then just like before, change 0 to sum. Right? It's the same steps we've done in doing the for loop. We've also done the work for the while loop. It just moves around a little bit. So it's doing the same thing. And then in general for the labs, the main that I give you is just yours to edit for when we use for testing. So you can comment out lines. Again, you can comment something out by doing on Mac, it's command/. On Windows, it's control/, I believe. You can just comment them out if you don't want to run that and edit it as you see fit. Okay, so that's middle. I'm gonna close that as well and not save it. And then for end, so we know here's the permit costs. So there's all these numbers in the array. And I think there's a table in the README. Nope. There's a explanation. So like students pay roughly maybe $10. Employees pay a range, and then a visitor pays up to $5 a day. Oh. Over here, that's where we want to go. And so we need to write logic here to figure out if I get a value, whose placard is it? So how did you do this? What code did you write?
I use everything like else if and else.
Mm-hmm.
I just said like, if. Essentially just like if a value equals, I think the first was like 9.91, then I said return to student. Because that's like, a student and then it's.
Yeah.
And I did else if value equals 0.0 and return disabled.
Yeah, and so on. And so then for, I think it's the same thing for like visitor. The only tricky thing is employee, where there's multiple options for an employee. And so we could say, like else if, val is equal to, what's one of them? 9.92 or 11.83, lab 1. Equals, or, and so on, right? So can either be a string of else ifs, or you could also do it by ors. Like one after another. The only thing is you need to have val equals equals on each of these if you're using the or logical operator. That's just the annoying part of it. And that's pretty much it. Does anybody have questions on the lab? Anything you're maybe still confused on? If the answer is no, that's great. That's exactly where we want to be. I just wanted to go over it just so that we're all clear on the how we're solving this problem. Okay, great. So we stopped at return types. Let's see if this is in my recents. It is. Okay, so last time we talked about kind of what Java is used for. Talked about things like copyright and royalties and such. Talked about comments. We talked about this. Here, let me turn on the PowerPoint. So we talked about this conditional operator, which is this kind of shorthand. This is called a conditional operator. That's the name of it, where we have the question mark and then do this if it's true, do this if it's false. We talked about methods, where we talked about here's the visibility of a method, whether or not it's static, the return type, and the method name. We talked about visibility being public, private, nothing, which means package visible, and protected, which we'll talk about this being something later on. We'll talk about what a subclass is. We talked a little bit about static. We'll talk about it a little bit more later, where static is basically we can make an object out of our class that we're working on. But so far we haven't needed to. And because we haven't needed to make an object, all of our methods have been static. And so that just lets us do like scripting type things. So like in Python, when you just write some bit of code and then execute it, that's scripting. That's mostly what we've been doing so far. So return types, I think there was one of the packet problems. Do I have my packet? Good. That's a packet. Right, so problem 2 has some different return types, like void, which just returns nothing. That's the return type of our main methods. No, we're not doing the lab yet. Void, it just means we're not returning anything. I will note that in a void method, we can still type the word return. We just don't type anything after it. We just have return semicolon. That just means we're done with this method. Time to stop. It doesn't pass anything back. Whereas last time, when we were computing the max, we returned a number, we returned an integer. And so that hands it back to whoever called it. For a void method, we can just return and then that's done.
Are you working on the packet?
I'm reviewing what we did last time at the moment. We talked about method names, which are basically variable name rules. So that was problem 3 on the packet of just which one of those are valid. Which ends up being ABC124, one with the lowercase a, and then hello underscore, this is a method. Those are the valid ones. We talked about parameters versus arguments. So when we define the function, so that's up here when we're defining the function, the things in parentheses are called parameters. Those are us defining, here's what I would like to receive as this function, as this method. And then when you actually call the function, the things that you give it, those are the arguments. And so that's why in main, we call that string array. We know that's a string array. We can read that now. It's called args because we could enter command line arguments, and the arguments are what gets actually passed to the program to run. So that's why it's called args. We can have two methods with the same name. That's problem 4. It's called overloading, which is where we can give it, we can have max of A and B and max of A, B, and C. And that's fine that they're named the same thing. It infers when we try to call max based on how many things we give it. It's like, if you give me 2, oh yeah, okay, go to this one. If you give me 3, go to that one. If you give me 4, too bad, there's no one with 4. So that gives an error. Okay, so we're going to talk about reference types for a little bit. We're going to talk about reference types kind of in general now, and more in detail when we start object-oriented. So you remember primitive types, right? Primitive types are your integers, your doubles, your Boolean variables, your single characters with different levels of precision. Those are primitive types. Those are very simple, and anything more complicated than that, we call a reference type or a reference variable. So the important thing to remember is what is a primitive type, and we can look at that list. Anything beyond that list is a reference type. So it's kind of like we know primitives, and then anything but we call a reference type. The way that it works is that for primitives, so this is kind of where I'm hand waving a bit. So the idea is the data that we have, the variables that we type, they live somewhere in memory. And the thing to know here is how they're handled depending on what type they are. So for primitives on the left here, the value is stored directly with the variable. So we've created a box somewhere in memory called age. That's the name of our variable. And the value stored there, the value is 5. So it's storing the value with the primitive. This is also true for a decimal number or a Boolean value, true or false, or for a single character, like X. X would be directly stored inside that box. For reference variables, we use something called pointers or references, which is why we call them reference variables. So if we've got a variable called P1, we've got a box in memory called P1, that's right here, but we don't have the actual value stored there. So for a primitive variable, 5 is stored there in the age box. For a reference variable, instead it stores a memory address, and it says, okay, I don't have the actual data here, but I'm going to show you where the data lives. So the data lives in memory location. This is a number in hexadecimal, because it starts with X. It lives in this memory location. Go there and you'll find the actual data. We as the programmer don't really see any of that. Excuse me. We as the programmer don't see like, oh, it lives as in another place. We don't see where the data gets stored. but it's important to know what's going on under the hood, because it affects the way that we talk about Java and work with the things in Java. So reference variables are handled by pointers or references, where the pointers or references, the pointer points to somewhere else in memory and say the data lives there. Or it references, here's where it in memory it lives. I know it's confusing, but this point is important. So primitives, and this is something that might show up on an exam. Primitives are handled by value. So remember this picture. So the value for age is 5. Primitives are handled by value. References are handled by memory address, where there's a pointer that points somewhere else in memory and says your data lives here. Okay. I think problem 5. What's the difference between a reference variable and a primitive variable? Yeah. So I have a few more slides just to like hammer this point home. So a primitive has like a Boolean or a byte or an int or something like that. It stores data directly. Primitives can only handle one value at a time. So like if we have an age variable, we can only hold one number. It takes less memory to store that because it's a simple data type and we're storing it directly. And so it's very fast. A reference variable, as opposed to primitives where we know exactly what those types are, there's unlimited reference variables. We'll create reference variables ourselves in this class. It's going to store an address to somewhere else in memory where the actual data lives. It can hold more than one value. It can hold a lot of values. We'll talk about that. Takes more memory to do that, and it may be a little bit slower. So reference variables stores a memory address, points to a memory address where that object is, and it can be anything. So Java lets us define and design whatever we want. So here's that list of primitive data types on the left, and on the right, we'll see like string is a reference type, an array is a reference type, list, set, and all user-defined classes. So all the things that we're going to define, those are reference types. Okay, so we're going to make a house class. And so we're going to make this class and we're going to give it some properties and some behavior. So let's say the property could be, here's where it is, the address. We can say, here's how many floors there are in the house. So like Garaventa would be, I think it has 3 floors. And maybe if the front door is open or closed, that could be another property. Like that's a binary yes or no. Is the door open or is the front door closed? Other properties you could think that we can give a house? Yeah. Color, yeah, what color the house is. Absolutely.
All material.
Wall material. Important things to know about, here's how this house was constructed.
Material.
Wall material, roof material, absolutely. Other ideas? Garage, like, what do you mean about the garage?
Like, would the other one say something yes or no?
Whether it has a garage or not? Yeah.
Likelihood to be destroyed by a Category 5 hurricane? What?
Likelihood to be destroyed by a Category 5 hurricane.
That very specific.
It does sound a little bit specific. So maybe that could be like a decimal or like a number between 0 and 1. like percent. Or something like that. Other ideas?
Know where you live.
Depends on where you live, yeah. So it depends on the address. Other properties? Maybe like,
Number of rats.
I was gonna say number of bedrooms, number of bathrooms. But number of rats also. Or number of pets.
Number of bathrooms, did we already do that one?
I don't think so. Number of bathrooms, I mean, that's an important thing to know about a house. If you're gonna go and rent a place, you need to know how, like, what's the bedroom and bathroom ratio?
And how far you have to go?
I also want to know how many rats are in there.
All right, all right. Yeah. What about behavior? So what sort of behavior could we assign to a house? This is a little bit tricky for a house example. But it could be like, is the front door open or closed? Or maybe if there's a garage and a garage door, is the garage door open or closed? Other ideas for behavior?
Like, on or off.
Lights on or off? Yeah.
Destroyed by a hurricane or not.
Yeah, that's also an option. Other ideas?
Feel like blinds open or closed.
Blinds open and closed. Let's see. Maybe we could, so far it's been binary things. What if we had like renovate? So like if we have a certain number of floors, maybe we want to add a floor to our house. We could renovate as a behavior that could be applied to the house. Other ideas in that line? Okay, so yeah, so we're gonna make this house class, this house type, reference type. In general, there are things that we're, as we create classes, as we create our own types, keep in mind that there's things that we want it to do. Those are like behaviors, and things we want it to keep track of or have. Those are properties. So properties and behaviors. Those are our two main categories. So we're going to define this new type. So it's not provided for us anywhere. We're the designers here. We're making this class. New types are going to go in their own files. So like you saw, we have like public class February 20th. It's going to go in its own file. So I'm going to make a new class called house. It's going to go in its own file. If later I wanted to create like a street type or an intersection type, all of those have to go in their own individual files. There's an asterisk there, but let's not worry about that for now. For now, all classes have to go in their own files. Okay, so I'm going to make a new class. So I'm going to type Command N, or you can go up here, or you could go File, New, Class. But I'm going to make a new class. I'll keep that package, the U2 More Java. That's the unit we're in. And the name of the class is going to be capital H house. I'm putting this in the in-class project. Because that's where all the code that I write in class goes. Okay, so all of these classes, like usual, we can ignore. I'm actually not going to click the public static void main option. I'm just going to leave that out for now. Then I'm going to press finish. We're good to go?
Public static void main.
No. Do you have a question back there I can
Yes,
help
so
with?
I uncheck that box.
Yes. Hold up, I'm gonna check the word. Yeah. Yeah. You might notice. You might notice that if I did this again and I didn't give it, well, if I type house again, then it says, no, you can't do that because something's already named that. But if I give it a lowercase letter, it'll give me a warning saying, hey, maybe not, because Java type names usually start with an uppercase letter. So that's why all of our classes, our .java files are capital letters. Okay, so now we've got our class house. So what we're going to do is we're going to set up our properties where those are going to be variables that we declare, and our behaviors are going to be methods. So our properties are things we want to keep track of. And then later on, we'll define our behaviors that we want our house to do. So keep track of and do. Properties, behaviors. You'll notice some people, if you look at code online, some people swap the two. They'll like list all of the methods first and then declare all the variables. Doesn't really matter. I tend to do the properties first and then the behaviors, but that's up to personal preference. So what do we say for our house? The address. So I'll store that as a string, which is just a quote list of characters. And typically here we just declare the variables. We don't initialize them. So we've got address, we've got number of floors. I want my number of floors to be an integer because it doesn't make sense for there to be a decimal number of floors, I guess. If we have maybe for bathrooms, because houses can have like 1.5 baths. So maybe having a double for that makes sense. The number of bathrooms. Because you know, like how like a full bathroom has like a toilet and a shower or a bath and a sink, but like a half bath just has like a toilet and a sink. So that makes sense to me to save that as a double. It's all because we're the designers here, and so we're deciding here's the properties that we want our house to have. And so then what sort of data type does it make sense to store that property as? So we're designing this as we go. Number of bathrooms. Does it make sense to store the number of bedrooms as a double or an int? Maybe? I feel like it's either a bedroom or it's not. So maybe we say int number of bedrooms. I said door open or closed. So what are the other properties we talked about? Garage. As garage. What else did we talk about? We talked about rats. Or maybe I'll amend rats to number of pets or number of animals. We had address, number of floors, number of bathrooms, and then 4 is number of bedrooms. Number 5 is whether or not it has a garage. And number 6 is the number of animals living there. Any other properties we want to add? Cool. So for behaviors, and let's say I want to have open garage door. This is going to give me an error. I'm just going to come up with the method names and then we'll fill out the rest of the signatures. So open garage door, number of floors, like renovate, which adds a floor. We could feed the animals. You can close the garage door. Now that I type garage, it's like the word has lost all meaning. Love when
What
that
else?
happens. The word garage. It's semantic satiation. Any other ideas for behaviors that we talked about?
But like a regular door is open.
Regular door is open. So we probably need a property to keep track of that. Boolean front door open. And so our behavior could be open front door or close front door. Other ideas? Okay. So let's fill out these method signatures. So when we're designing methods, we're pulling from the properties, right? So we have this data that we're keeping track of. And for the methods, maybe we're manipulating that data in some way. And so we want to think, what is it doing? And do we need to return anything? So like for open the front door, what should it be doing? First of all, what property are we looking at for this one? Yeah. That's our variable. And so if it's a Boolean,
Open front door like through something.
yeah. Yeah, so the idea is front door open is now true. Is there anything else we want to do in there? Yeah.
Create the method signature.
Well, yeah. So I mean, like, in terms of what we're actually doing.
Yeah.
Yeah, so we're just opening the front door. So it's fairly simple. So do we need to return anything? Yeah, that's an option. We could also not. Like, like this is where you as the designer could make a decision where I think maybe we don't need to return front door open. You may think that, oh, I really want to return that information. So the method type for the method return type for me, at least, is void. If you wanted to do return front door open, then you would make it a Boolean return type. But for me, I'll just go back to void. Okay, we have to say it's visibility. So the visibility for this matters because if we make it private, then only things inside of this house class, only inside of this Java file, are we going to be able to call open front door. So with that knowledge, do we think it's a good idea to make this method private or public? So that is, if we have a main method here, let's say in our main method, we can call, if we have like a house H, we can call H dot open front door. But it also means that if we're in another file, I cannot say open front door because I can't see it. Do we think this is behavior that we want?
And then whatever methods.
I'll go back to it in a moment. Who votes for making open front door private? Why do you think private?
So you can only access it in that. But
Mhm.
if we're working in another one, we can.
So maybe it does make sense if we don't want like anyone to just come up to our house and open the door. Maybe we want to have some like sort of security system. That's a possibility. Who thinks we should make it public?
You didn't make a lot.
Right, we didn't design this house to be locked, so yeah. I'm just, so this is the one I created at the very beginning, which is just our like test class for today. But we're walking through house.java. Okay, so in this case, let's just make it public so that I can open my house door in the other file. Here's where we don't make it static, because we're going to have a house object. And so when we have what's called a controlling object, so we'll have a house object that has this method open front door, we don't need it to be static. So it's just going to be public void this. Maybe if we wanted to have a security system, we could be like, give me a key, and then maybe check if the key is good, then open the door, otherwise not. But I'm not going to worry about this for now. I have another example that we'll talk about later that that gives us that. So for now, I'm just going to say no parameters, just set front door open is true, and then we're done. So close front door is going to be fairly similar, where let's say it's public and then also void. And then what do we want to do in close front door?
Make front door open policy.
Yeah, because in one, it's true. In here, it's going to be false. So front door open equals false. And so this works, it's going to work similarly for open the garage door and close the garage door. So we'll fill those in. So public, void, open garage door, and has garage is just, here's where it kind of doesn't match up with the operation that we want to do and the data that we have, where the data that we have is just has garage. And so if we manipulate has garage, then it's either we open the garage door, oh, we have a garage. Otherwise, when we close garage door, oh no, we don't have a garage anymore. The garage has disappeared. Okay. So maybe I changed has garage to garage door open to more align with the behaviors that we want to see. So we can say, copy this, garage door open equals true. And then for close garage door, we have public, void. And then garage door open is equal to false. For renovate, which we define as adding a floor, we could also define renovate to be like add another half bathroom or something like that. We can define what we want this house to look like. So for me, if I say that I want to add a floor whenever I renovate, I can make that again a void method. And say, what is it? Num floors plus equals 1. And then I can also print something like we've renovated, right? So a method is just we can do whatever we want in here. We feed animals, maybe. Non-animals. Have been fed. I'll let that park for a second as you type. Okay. Are we good to move on or do we need more time? Okay.
Or can only have one bedroom each. So we made a function that has a bedroom and the number so if we made a function that adds a bathroom and each floor can only have two bathrooms,
Like limit it in some way?
yeah, limit it as in if number of bathrooms is
Yeah, like compares to the number of floors. Yeah, that's an option.
it's four times.
If that's how you want to set up your house, then go for it. Okay, how about now? We good? Okay. I'll also post this on Canvas. Let me remind you where that's gonna live. If we go to the main Canvas homepage. Wait, let me view it as a student. This very top module, if you go to the lecture links page, I've recorded all the lectures and they live here. The one for today is going to live right there. And I link, here's the files that we talked about today. So like you can click on that and see, here's the code that I wrote last time. Okay, leave student view. Just to remind you, that's continually available. All right, where were we? Over here. We can also have what we call methods. Remember, the functions in Java are called methods. We can have methods to just query what's the status of the variables that I have. The variables are called fields in Java. So these properties, things we're keeping track of, the variables, those, the official name is called fields. And then these, the behaviors, those are called methods. That's just the official name for them. But sometimes I just want to know, what is the address? What is how many floors do we currently have? How many bathrooms or bedrooms are there? And I can do that with something called getters and setters. Getters are what I was just talking about, where we can get that information. So either we can type them ourselves, where we can say, those are typically public because we want other people to be able to access them. We'll typically call them get, and then the variable name. And then we just return the relevant field. So return number of floors. So that's a getter. There's also what we call setter methods, which you might imagine allows us to set the status of that variable. So something like open and close garage door and front door, those are setter variables because we've now set the value of front door open and garage door open. So this is a setter. This is also a setter. That's a setter. Renovate, while it manipulates the number of floors, I wouldn't say that it's a setter because it just increments. So it's not quite set the number of floors as X. It does something like restricted and different. Yeah, it's a modifier, and not just a setter. Similarly, feed animals. It's neither a setter nor a getter because it's just printing this many animals have been fed. The setter for number of floors might look like public int set num floors. And so here's where we would have a parameter. Remember, the parameters are what go in the parentheses, where we can call it, we can give it whatever variable name we want. We can call it n, we call it x, we call it a, call it nf for number of floors. We could even call it num floors, like the same name as our field. It's possible. It lets us do that. The way we distinguish between the variable in the parameter and our variable of num floors, so the one that lives up here, we can distinguish between them with a keyword. The way that we look at our version of num floors is this dot num floors. So saying this dot num floors refers to the field and not the parameter. And once we type it in and we add the semicolon, for me, it turns pretty colors, and the pretty colors help tell you which one is which. So the blue one, that's our field. And so this is a keyword, the word THIS, that's a keyword. And so that's purple. And so this dot num floors, when we type that, num floors becomes blue. That tells you it's a field. While the num floors on the right-hand side is a kind of brownish color. And that's the same as
It's,
the parameter.
it's this dot really necessary, and when is it necessary?
If I do that, then this is not, the num floors on the left-hand side isn't blue. And so it's not clear which one is which. So it's gonna take that to be the parameter. So in this case, when they're named the same thing, we need this dot. If we had named num floors n instead, then we don't need this dot. So only when the parameter and the field are named the same thing do we need this dot. And we'll keep practicing with this. We'll get a lot of practice as we go of designing classes and practicing these skills. So I'm gonna undo things. I'm gonna go back to where we have this dot. Are we good? Okay. Undo. Undo. There we go. Okay. I'll show you a tip. So for Eclipse, and this also works in VS Code. If I want to, so generating getters and, or like typing getters and setters may feel like a bit tedious at this point because it's just set this variable, get this variable, and so on and so forth. Eclipse can generate like basic code to do this for us. Let me see if I remember where it lives. So if I right click out here, source, and generate getters and setters. So right click outside. So I've got, this is a method inside my class. I'm clicking outside of that. And, but still in the class. And I right click. And I go down to the source option. Down to the source option. And then there's an option, generate getters and setters. Generate getters and setters. Are we there? Cool. Click on that. A little dialog box shows up asking, which ones do you want? So we've got all of these fields and it wants to know which ones do we need them for. So address, I would say yes. Front door open and garage door open, I would say no, because we've already got that. But we've got the setters at least. H, what is H? Oh, that's down here. Ignore that. Number of animals, number of bathrooms, number of bedrooms. Notice that num floors doesn't show up because we've already made it. So since we've already made it in with that formula of get variable name, it ignores that because it's like, you've got it. Why should I give you the option? You don't need it. If we expand that a little bit, it's gonna, like, we could choose to get the number of beds, but not set the number of beds if we wanted to. So you can check, make sure one or both of those boxes are checked. Yeah.
You said we can see enough floors in there, so we did both of them. If we were to do one of the two, would the other one show up in there?
That's a great question. I'm gonna escape from this and comment one of them out and let's see. Okay, so I'm gonna comment this out with command / and
Shouldn't set num floors have a return?
you're right, it should. Wait. Do we want to return something? I don't think so.
So why not put a breakpoint in?
It should be void. Thank you for catching that. I was just copying what I did in get. But for when I'm setting something, it doesn't really make sense to return anything. Okay, so now that I've commented this out, go down to source and then generate getters and setters. Yeah, so see now number of floors shows up and set is an option. And so you can see kind of the formulaic way that it generates them. So like for Booleans, the options are is for a getter, because for a Boolean, you want to know like, is it true or false? And then set, obviously, for set it as true or false. For the others, it's mostly get and set. So Boolean has the small exception for is for the getter. Okay, let me uncomment that. And now let's actually get them all. Generate getters and setters. Address, number of animals, number of bathrooms, number of bedrooms. There's other options here. Allow setters for final fields. We'll talk about what final fields are. It asks, where do you want to put them? You can say after, you can put it first, you can put it last. Yeah.
My number of floors still showing.
What have you named the method? My guess is, so the formula tends to be the word get or the word set, and then capitalize the first letter of the variable, and then it's just the rest is the name of the variable. So I'm guessing if it's called something other than that, then it's going to pop up. Hold on, I'll come around and look at it. The other options, we can sort it. So either we get all of the getters first and then all of the setters, or it's getter, setter, getter, setter, getter, setter. So that's getter and setter pairs. Doesn't matter. That's mostly up to you of how do you want to organize it. For access modifier, we've kind of talked about like, do we want it to be package visible or protected or public? I'll just go with public. We can generate JavaDoc comments if we want. I don't want to do that because it's gonna be a lot. You can click this box and see the sort of method comments that it gives you. It's fairly verbose for the simple little methods that they are. And then, yeah. So if I click generate, now that comment doesn't really mean anything anymore. We've got get address, set address, get num bath, set num bath, get num bed, set num bed, and so on. So here I will close I'll delete those. Okay. We on board so far? Great.
What about the lab?
We're not there yet. At the end of this slide deck, I will talk about the lab. I misspelled that. We've talked about this. We've talked about this. So properties are called fields. The behaviors, things to do, those are called methods. Those are just the official names that we apply to this. We did that already. So now is where I'm trying to teach you the terminology as well. So now we've got our idea in the sky for this is what a house should look like, right? We've got our house that has number of floors, it's got an address, it's got all of these other properties, and it's got things that it should be able to do. But this is still just our outline, our idea up in the sky. We don't have an actual physical house yet, right? It's the difference between having a blueprint and having an actual house that's built, right? That distinction is important. So we've got our house type, but we don't have a house object yet. So we need something to be able to make our house. We have to construct it. And this is like having an outline for a book or an essay versus actually having like a finished essay that you can turn into your professor. So we need a constructor to be able to do this. And so we'll define a constructor that actually takes in some initial values and then sets our fields to be equal to those values. And then once we've done that, then we can actually do something. But first we need to say we need to define the constructor inside the house class and then say, here's what you need to do to actually build the house. So we've got a blueprint, but we need instructions. I typically like to put my constructors after the fields. Again, doesn't really matter. When we're writing a constructor, we need only the visibility modifier. So I'll make it public. And then the name of the class. So a constructor is not a method. We just have a visibility modifier and the name of the class. The name of the class must match exactly the name of the class up here. It also must match exactly the name of the file. So this is something that I see especially in early in this class where maybe there's something else that's the class name and it's like, why isn't it working? It's because all three of these things need to be the same. So we've got capital H house.java, public class capital H house, and then for our constructor, it's public capital H house. In here for the parameters, this is where we define, here's how to set up the initial values. So ideally, someone is going to give us some value. So like maybe they're going to give us an address and then we can just say, let's actually do that. So let's say someone's going to give us an address and now we've got an address. We can set that as our address. Someone has told us, here is where your house is going to live. So let's say this dot address is equal to the address parameter that I was given. The other things that constructors need to do is just like set things up. If I didn't do anything, the default is it's going to give us, so for primitives, it's going to initialize them to zeros or false. For numbers, so like number of floors would be if I didn't do anything, it would automatically be initialized as 0 floors, 0.0 baths, 0 beds. You get the point? For reference variables like the address, if I didn't specify address at all, so if I didn't do this, then it would initialize address as the empty string, which is just 2 quotes next to each other. It's the most boring string. There's nothing in it. So it's empty. It is technically a string, but there's nothing in there. So if I didn't specify anything, an empty string, that's what it's called. Yeah, so it would just be empty. So that's what it happens by default. If we want it to be something other than that, we have to specify it in the constructor. So if we want to set it up as you give me an address and I say, okay, here's the address, you have 1 floor, and we can set up like default, like 1 bedroom, 1 bathroom. the garage door is initially closed, the front door is initially closed, maybe you don't have any pets to start with. If that's what we decide is the default house, we need to say that this is what the default house is gonna look like. So we'll say this dot address is equal to the address that's been given to us. Num floors. Maybe we'll just start at a one-story house. Maybe we could start it off as like a studio apartment. So like studios typically have a full bath. So num bath is equal to 1. Num bed is equal to 0. So studios are like all one room. And then garage door open, let's see if this works, equals front door open equals false. Yeah, that works. So this line allows us to set both front door and garage door as closed. Just in one line. Maybe initially we assume that there's no animals. If you're working for a building company that only takes clients who have 5 dogs or like 5 pets, then you would assume that the number of animals would be 5 because that's what all your clients have. So this is where it depends, like we're defining what default means. We're defining what that looks like for our house. We're the designers here. If the situation looks different, the default will probably look different. Okay, I think we got all of the fields. This comment is an example of the kind of summaries that I would like to see in your assignments, where I have a bunch of codes, and to me, this says that like, especially the number of bathrooms and bedrooms, to me, that says studio apartment. And so I just want a comment there saying, this is a studio apartment. This is the meaning of these lines of code that I've just written. So a helpful summary before some things that maybe you would need to explain if you were talking about this code to someone else. Just put it in a short comment, and that's what I'm looking for. You'll see this on homework assignments too. Like sometimes I'll give you part of my rubric is like, do you have comments? So make sure you do have comments somewhere. Doesn't matter so much for the first homework because that's just us getting started, but going forward, and this will also be a point in the lab of just make sure that you have comments to explain. It doesn't need to be super verbose. I've had students in past semesters like use AI code and submit that. And they're like, I just did it to like help with commenting. And I'm like, that's great, but
Just to help with commenting my ass.
pretty much. Where if you wrote the code, I want to know what you would say about it in a sentence. Like, what did this code just do? If you could say it aloud, write that down, good enough. Okay. So that's one of the constructor options. Both VS Code and Eclipse can let us generate constructors as well. So one of the options down from getters and setters is generate constructor using fields. And so that's going to give us, again, a super bare bones constructor. It's going to let us select what fields do we want to be able to input. So we could select all of them. We could select some of them. I would probably not want to say garage door open and front door open. I think the others probably make sense to be able to initialize. To specify, here's how many, it's like your,
Which one is this?
this one is if you right click in the class and then go to source and then generate constructor using fields. So yeah, and then the rest of it is it's similar, where like where do you want to put it? I'll make it public and not private. You can generate comments. The one for me that's checked is omit call to default constructor super. We'll talk about what that means later. We'll talk about the super constructor later. So I've clicked address, number of floors, number of bed and bath, and number of animals, and I'm going to generate it. And so it gives me this. So it just has generated some code and given it to me. If I want to customize it, I can. It's also given me a Java comment, saying, here's the different parameters that go into this constructor. If I want to add anything there. This is where I say this explains what this constructor in particular is doing. Now if I hover over that, anything that I type, I can see when it hovers over. So that means when I call this constructor elsewhere in another piece of code, I can be like, oh, wait, what's this thing actually doing? I can refer to the comment that I wrote, and that can tell me, oh, yeah, okay, this is what it's supposed to do. It's supposed to take this, this, and this. Okay. Are we good so far? All right. So now we've got a constructor. So I think we have time. We might get to having a main method and creating a house object, and then that might be our stopping point for today. So now we've got our blueprint and we know the instructions for how to put our blueprint into reality. So let's make that happen. We need a main method to run the program. And the question is, should it be in house.java, like right down here, like public static void main string args down here, or should it be somewhere else? The answer that I will give you is, I think it should be somewhere else. We'll talk about this once we'll look at an example probably on Tuesday, for combination lock chances, at least some point in the future. But we'll look at what having a main method in the class does in terms of knowing the combination versus doing something with the lock outside of the class. So for now, my answer is put it outside. And so here, so we tend to prefer, and I would prefer that for the classes that you write for this class, we use the word class a lot here, have what we call a driver class, which is we've got our house class, house.java. We need another .java file, our driver file, to actually test it. So name it housedriver.java, or since I've got my February 20th file, I'll just do it in there. So similar to other kinds of variables, I can declare my house variable that I just created with capital H house and then H for H is the variable name. I could name it my house or whatever. Name it whatever I want. But I'll go with H. So that's declaring. And now I can do what's called not initializing, but instantiating, which is where I say H is equal to new capital H house. And I'm going to give it an address. I'm going to say we live on 123 Main Street. I've created my house now. I've created a house that, because I've defined, this is what we're doing here. We're calling the constructor that we wrote. We wrote the constructor that takes in just a string and it does all of these things. We defined what happened there. And so when we say new house 123 Main Street, we've created a space in memory for our variable H. And so now H points somewhere to a house object that has all these bits of data, that has the information of number of floors, number of animals, is the garage door opener closed, is the front door opener closed. Now we've got a structure like that in memory that we can work with. So we can, let's maybe print the address. So the way we do that is we say the get address is a method that belongs to a house, right? We want our house to be able to have this behavior to tell the user, where do you live? So the way that we access it is h dot get address. And so if we do this and save it, there's no more errors here, so I'm going to run it. And it prints 123 Main Street. You will be able to access them on the lecture links page. But that'll be after, like, in the evening, because I have to go and post them. But I'll make sure that you can access all of them. I can even print the variable. If I print it and run it, it gives me something that's not especially useful. It tells me here's the name of the type and what's called the hash code. So maybe it's trying to approximate where it lives in memory, but not quite. But yeah, so now I've got an actual house object. And my house object is named H. I have instantiated that. I've made it an actual thing. Okay, so we'll talk more about this next time. We'll keep going in the slide deck.
What about lab 2?
Lab 2, you can just sit tight on that. For active learning today, please submit
Class?
the house class. Exactly. Read my mind.
Yes, because I already did it.
Great.
Well, you weren't.
Save.
And what about the packets?
The packet, hold on to it. I think we may have, I'll leave some time. Next time we're gonna go in through and fill in some of these things. We're probably, we kind of skipped 6 and 7. So maybe we would start at 6 or 7. Okay, that's all I have for you. Thank you. Submit active learning and I will see you on Tuesday.
You want us to Java and house Java?
Just house.java.
Okay.